Hello, in this video we will talk about Chebyshev's inequality and the one-sided Chebyshev inequality. So Chebyshev's inequality states the probability between a range of data. So if, for example, we know X bar and S be the sample mean and sample standard deviation of our data. So we does not need very difficult calculation to know exactly what is the probability between two values. But we can conservatively to state that there is about at least 100 times 1 minus 1 divided by k square percent of the data lies between x bar minus k times s and x bar plus k times s. So what does this mean? For example, if we know k is 1.5, then we can say at least about 55.6% of the data lies between 1.5 times 1 times standard deviation around the sample mean. So we can say x bar minus 1.5s and x bar plus 1.5s. So this range contains at least 55.6% of the data. So this is for any data, and we do not need to know the distribution, what kind of distribution of the data. So this is a very conservative statement. And for example, if k is 2, then we can say about 3 or 4 of the data lies between 2s around the mean. So it's mean minus 2s and mean plus 2s, this range. So for example, we take a look at an example. This is passenger cars data in USA. And we can get the sample mean and sample standard deviation. So we know this value is the square root of sample variance. And sample variance is the average difference around the mean, take a square, but this average is divided by n minus 1. Because this is sample variance, sample standard deviation. So we get these two values, and we can say about 55.55% of the data lies in this interval, x bar minus 1.5s and x bar plus 1.5s is around this value. But this is conservative, and actually about 90% of the data falls exactly within this range. So Chebyshev's inequality is very conservative. We can say at least larger than this percent. So actually it's 90% if we want to know the exact data of this data. And another question is, suppose that we want to know the fraction of the data that exceed the sample mean around k sample standard deviation. So this is on the contrary opposite case, because in Chebyshev's inequality, we state that at least how much percent of the data lies lower than the k standard deviation around the mean, right? But here if we want to know how much percent of the data lies outside k times standard deviation around the mean. And one may think this is just 1 minus the data, the percent of the data we get from the Chebyshev inequality. So this is not wrong, because if we know this is the number of data larger than ks around the mean, then we can say this is the proportion, or say percent of the data larger than ks around the mean, is less than 1 divided by k squared if we get the answer from Chebyshev's inequality. So larger than the k standard deviation around the mean is less than this proportion, right? But we can get a more accurate or a stronger statement if we want to know the range of data outside of the k standard deviation around the mean. Actually, this is just 1 divided by 1 plus k squared. So here we have to plus 1. So this is interesting. And the inference of this result we are skipped. We just get the result of this one. So the proportion of data range outside of the k standard deviation around the mean for any data is less than 1 divided by 1 plus k squared. So for example, if you want to know how much proportion of the data lies outside of 2 standard deviation around the mean, so from the one-sided Chebyshev inequality, we can get about at most 20%. At most 20% because k is 2 here. So 1 divided by 5 is 20%. So this is the one-sided Chebyshev inequality. So in this video, we just talk very briefly about Chebyshev inequality and one-sided Chebyshev inequality. And we have a website, rdatacode.com, for Python and R training. So if you are interested in for the data science and statistical programming using R or Python, so you can check this website. And here are the course registration. So we have both Python basic course and R basic course. So you can register from each link. Click here for registration, and we have course on weekend. We think about the different time on different time zone. So you can check time. We have weekend 8 hours course, about $10 for the total, for either for the Python course or the R course, but they divided into 2 days. So each, on the weekend, 4 hours per day. So thanks for watching.